If you're a Python programmer, you should really learn about sockets. Sockets are the cornerstone for communicating over the network, generally in computers and specifically in Python. So if you want to add to your Python applications the ability to communicate over the network, learning sockets is the way to go. So what we're going to do in this video is learn the basics of sockets by writing a simple application. It is going to look like this. We're going to have a server, and then we're going to have clients. And you can have only one client or many of them, 20 if you want. All of the clients will communicate with a common server, and whenever any of the clients sends a message, this message arrives to the server. And then the server forwards this message to all of the other clients. So this is how it's going to look like. As you can see, I have here 3 clients, each with their own username. And now when I send a message from any of these clients, you can see the message on all of them. And if we send another message from another client, we can see that it got to all of the clients as well. So to get started with developing a socket application, we're going to need a server and a client. Let's start with the server. So I'll create a Python file for the server and I'll simply call it server.python. We're going to work with sockets, so we would better import socket. And to keep things in order, I'll manage the entire server as a class. So let's create this class. And in this class, I want a method that will set up the server. We will implement this method in a second, but first I want to create an object of my class in the main program. So that's great, and we'll now have an object. So, how do we set up our server? The first thing we need to do is to define an IP address. This is going to be the host address. Now, the IP address we provide here as a host determines to which network interface our socket will bind to. For a client to successfully connect to our server, it needs to access the IP address we provide here. So if, for example, you have multiple network interfaces in your computer and you only want to allow connections to one of them, you're going to define here the IP address of the server that's connected to this network interface. Other network interfaces will have nothing to do with the socket and won't be exposed to connection. In this case, I provided the value for localhost, which is 127.0.0.1, and it means that only clients from this specific machine will be able to connect. If you provide the value 0000, it means that you allow connections on all of your network interfaces. So if a client is able to see the server, it's also going to be able to connect to the socket. But for this demonstration, I'll go with the localhost IP address. The next thing we need to provide is the port, and this is the port that the server will listen to. And now let's create the socket object itself. Now, as you can see, the constructor of the socket gets 2 parameters. The first one is the address family, and that's where we provided af_inet. And if we provide this value, af_inet, it means that we want our socket to work with the IP version 4 protocol. So IP version 4 is still more widely used than IP version 6, and that's why I decided to use it. The next parameter, sock_stream, means that the protocol on top of IP is going to be TCP. In applications where it's crucial to make sure that no data loss or corruption happens due to networking problems, we usually use this protocol, the TCP protocol, which, as we said, is represented by this constant, sock_stream. And also, let's call our setup server method from our main program. And now we can actually start using our socket. So using the socket on the server side basically involves 3 steps. First, we need to bind the socket, then we need to make it listen, and eventually we need to accept connections. So let's start with binding the socket. And as you can see, the bind method takes a tuple as a parameter, and in this tuple we provided the values for the host and for the port. We then want our socket to get into the listening state, and to do that we use the listen method. And as you can see, we need to provide a number as a parameter that determines the maximum number of concurrent clients that the server can take care of. Once we did these 2 preliminary steps, we can call the accept method, which is a blocking method, and will make our program stop and wait for an incoming connection. Now, one thing we should take into account is that since the accept method is a blocking method, it's going to look like our server application froze. So we're going to run it and then it's going to look like it's stuck. In reality, it won't really be stuck. It will just be waiting for incoming connections. But to give the user better understanding of what's going on, we would better provide some indication that we're about to accept incoming connections, and then when the server just waits there, it's clear that it's waiting for connections. So let's print just that. And this is going to be the first version of our server. If we now run it, we can see that the server is listening on this host, on this particular port. Now, at the moment, no client is going to make a connection, so the server is just going to wait here indefinitely. So now seems like a good time to start creating our client. Let's start by creating a new Python file for the client. And once again, we're going to import socket. And to keep things in order, we're also going to create a class for our client. And for the client, I just do the initialization in the init method. So just like in the server, we're going to need a socket object. And notice that the parameters that I passed when creating the socket object are the very same parameters we passed when we created our server-side socket. And that's because it's going to use the same address family, or basically the IP version 4 protocol. And also it's going to use TCP on top of IP. And to specify the TCP protocol, we use sock_3. Next, we need to specify the host. But here, the meaning of the host is a bit different than what it meant on the server side. On the server side, it specified the network adapter we wanted to listen on. But here, this is the destination, the IP address of the server that we want to connect to. In this example, we're using localhost, so both the server and the client reside on the same computer, on localhost. Next, we need to specify the port, and the destination port for the client has to match the port that the server is listening on. So, of course, I used the same port that we specified on the server. And now we're ready to create an instance of our client class. Now that we set the client up, we're going to be able to connect to the server. So since the server calls the accept method on its socket, it's going to be waiting for connections. By using the connect method on the client, we're going to create such a connection between the client and the server. And notice that as a parameter to the connect method, we passed a tuple that consists of the destination host and the destination port. Let's now try to run our server. And we can see that the server is running and waiting for incoming connections. And if we now run the client, we can see that the client runs and finishes running. But if we take a look again at the output from the server, we can see that it also stopped. And that's because as soon as the client connected to the server, the accept method returned. So as long as it was waiting for incoming connections from clients, the server's application kept running. But as soon as such a connection was made, the accept method returned and the server application finished running. So this is working great. But the problem we currently have with our server is that as soon as a connection is established with the first client, the server stops running and as a result, stops listening to additional connection requests from other clients. That's probably not what we want. A server that can only connect to one client is usually not a very useful server. What we do want from the server is to create the connection with the client and then keep listening to additional connection requests from other clients. And we want to do it repeatedly. So every time a client accesses the server, a connection will be created and then the server will keep listening to more clients. To achieve that, we're going to move the call to accept to a while loop. Now, by the way, the accept method returns a tuple. And this tuple consists of two values, a client socket and an address. So first, it's very important to understand that this socket is a socket just like the one we defined over here. So we have this socket, which we call server socket, and then we have another socket, the client socket. And I want to emphasize that even though this and this are two objects of the socket class. They are different sockets and they will serve different purposes. The server socket is in charge of listening to connection requests from clients. Whenever such a connection is established, we're going to have this kind of socket, the one we call client socket. And this is the socket that we'll actually use to communicate between the client and the server. Now, during the whole lifetime of the server, it will only have one server socket, because we only want to use one socket to listen to connection requests. But each client is going to have its own socket, its own communication line to the server. This is the client socket, and using this socket, the client socket, the server and the client are going to be able to communicate with each other. So we define the server socket ourselves, and we're going to get the client socket as the result of the accept method whenever a client connects to the server. Now, the address is the address of the client that just connected. So to see the difference between different clients that connect to the server, let's print the value of address. And now our server is going to be able to connect to multiple clients, each having its own client socket, and whenever such a connection is made, we're going to see the address of the client that connected. So let's run our server, and let's now run the client, and this will create a new client and immediately connect to the server. And we can see that the client ran and exited. But if we look at the output from the server, we can see connection from, and here we can see the address of the client that just connected, and we can also see that the server is still running. It's still listening to additional clients to connect. So let's run an additional client. And if we look at the server again, we can see that another connection was made, and we can see a different address. Now notice that all of our clients are going to have the same host. And this is to be expected because in our example, the server only listens to this IP address, so all of the clients have to use this IP address as well. This is localhost. But as you can see, the port for each of these clients is different. Now you might notice that we did not define these numbers, this number of ports anywhere. This is done automatically by the operating system. Whenever a client wants to make a connection to a network socket, the operating system assigns a temporary port for this connection, and this is the number of ports we see here. Once the communication socket with the server is closed, the resources used by the socket are released, and then the port will be released as well, and the operating system will be able to reuse this port number. Let's try connecting with a third client. And here we can see a third connection with a different port number. So as we said, the client socket is the socket that's going to be used for actual communication between the client and the server. So let's prepare our server to get some actual data from the client. What we'll be expecting is the username. So we'll be waiting for an incoming message, and when it arrives, we're going to use it as the username for this specific client. Now to receive a message from a socket, we're going to use the receive method. And as you can see, we had to pass the maximum number of bytes that the server will be expecting. For a username, it's a very reasonable assumption that it will require less than 1024 bytes. Once we get the username from the client, let's print it. And here I want you to notice something important. As you can see, what we got back from the receive method is the username. But what we printed here is not the username itself, but username.decode. The reason is that what's returned from the receive method is an array of bytes. So what we have in this variable, username, is an array of bytes. But here we want to print a string. So to convert to a string, we use the decode method. And now that the server is waiting for the username from the client, let's send it from the client. So here, after calling the connect method, our socket, this socket, client socket, is supposed to be connected to the client socket on the server side. So what we can do is use this socket to send the username. So to send something through the socket, we use the send method. For the username itself, at the moment, we just used the client string, but since we need to pass a byte array to the send method and not a string, we had to use encode. And encode converts a string to a byte array. There are many ways to encode a string to a byte array. Here we used UTF-8, but unless you're dealing with something very specific, UTF-8 will usually do the job. So after encoding a string, it will be converted to an array of bytes, and then we send it through our socket. So once again, let's start our server. And it's listening. And now let's run a client. And if we look at the output from the server, we can see that we got a connection from this address, and then we can see client connected. So here is the code for the server, and we can see that the username sent by the client is displayed on the server. Let's run another client. And here we can see another connection, and then we can see the data that was sent from this other client. Getting back to our server, there is an important point here that we have to take into consideration. The receive method we used here is blocking, which means that as soon as the server starts waiting for a message, it won't be able to do anything else until this message arrives. Now, at the moment, it works fine because we assume that as soon as the client will connect, right after the call to accept, it's also going to send a message containing its username. And that's what we're going to get in this call to receive. But what if we want to be able to get additional messages from the client? Adding another call to receive inside our while loop is going to be problematic. And that's because the purpose of this while loop is to wait for connections from new clients. If we are going to be waiting for messages from some specific client, we won't be able to accept connections from new clients. Now, given that we're developing a chat application, you never know when the next message from the client is going to arrive. It can be in the next second, or it can be in 10 minutes from now. And the conclusion is that adding another calls to receive inside our while loop is not a good option at all. So how are we going to be able, on one hand, to keep listening for connection requests from new clients, and on the other hand, to take care of messages from clients that already connected before? The answer is that we're going to use threads. For every client, we're going to create a thread right after the connection is established. And in this thread, we're going to receive the messages from this client. This way, the while loop in the main thread is going to stay available to new connections from new clients. So let's start by importing threading. And now let's create the new thread for the new client right after we get its username. And I want you to notice a few things here. First, we set the target of the thread to handle client. This is a method that we're going to implement in a second. Secondly, as a parameter for the new thread, we pass client socket, which is the socket we use for communication with the client that just connected. This way, we're going to forward all of the responsibilities that have to do with the client socket to the new thread we're creating. So let's implement our handle client method. And all we're going to do in this method is write a while loop that keeps listening to incoming messages from this client socket that's connected to a specific client. Every time we get some data from this client, we're simply going to print it. And once again, since the data that we get from the socket is an array of bytes, we have to use decode to convert it to a string. All that's left is starting our thread after the new client connected. And this way, we're handling messages from this client in a different thread. Now that our server can handle messages that are sent from the client, let's add the ability to send such messages from the client. Now, sending messages from the client on command is something that I find a bit easier to do from graphical applications. So this is a good time to create the graphical user interface for our clients. Since I'm really trying to focus on sockets and communication, I really don't want to get too deep with the user interface for this application. So I just implement something basic and it will do. We're going to use tkinter for the user interface, so let's import it. And our client class is going to inherit from tkinter. In every class that inherits from tkinter, we need to call the init of the parent. And now I'll add the UI elements themselves. So once again, I don't want to get too deep into that, but basically we have here a label that says name, and then an entry for the user to enter the name. We're going to have a connect button, and then we're going to have a big text box to show the messages themselves, and eventually we're going to have another entry and a button for the user to send new messages. And just like in any tkinter application, we need to call main loop. And let's take a look at how our client looks now. So first let's run the server and then the client. And here is our client. And the first thing we're going to use from this user interface is this entry box and the send button. And this will allow us to test our handling of messages from the client to the server. Now, for the send button to actually do something, we have to connect it to a function. And whenever we click on the button, this function will run. So the name of the argument in the creation of the button that determines the function that will run when we click on the button is called command. And this way, we connected the button to this method that we'll write in a second. And whenever the button is clicked, this function will run. So let's implement this function. And what we want to do in this function is to simply send a message for the server to be able to receive. So I'll define a string here. And then I'll use the encode to convert this string to an array of bytes. And once we have this array of bytes, we can use the socket.send method to send it to the server. So here we converted the string to an array of bytes, and then we use the send method of the socket to send this message to the server. So let's run our server, and let's now run the client, and let's look at the output from the server, and we can see that our client connected. And if I now click on the send button, we can see the message we just sent, which is hello from client. And if I click on the button again, we get the same message again. Now, this will also work if we have another client. So let's run another client. And you can see that the connection from the other client was created. And I can now send my message from this client, and it is received in the server, or from this client, and it is received as well. Now, at the moment, our client connects to the server as soon as we start the client. So as you can see here, we call the connect method, and this line is just inside the init method. So as soon as we start running our application, the init method is called, and right after that, we call the connect method. I want to change it, so only when we click on the connect button, the client will access the server and create the connection. So let's connect this button, the connect button, to another method. And I call this method connect to server, so let's create this method. And now I want to move this line that creates the connection with the server, and the line right after that, that sends the client name to the server from the init method to this new method that will be called when we click on the connect button. And one other thing I want is, instead of always sending client as the username, I want to actually use what the user entered to this entry box. Okay, so here we expect the user to enter their name, and this is going to serve as the username. So I'll get the text from this entry and use it as the username. And now, instead of just sending this hard-coded string, I can use the actual username. Let's now run our server, and let's enter a username. And notice that as soon as I click on the connect button, this client connects to the server, and you can see the username that connected. Now, at the moment, when we click on the send button, which is connected to this method, we always send the same message, hello from client. Let's change it so that the message that is sent will be the one that the user entered to this entry. So instead of this hard-coded string, I'm going to use the text in the input box. And let's also clear the content of the input box after we send it to the server. So let's run our server and the client, and let's run another client. So let's connect from the first client and from the second one. And now we're going to be able to send any custom message we want. Another thing we want to do in the client is to prevent the client from connecting to the server a second time. So after the connection to the server was made, I want to disable the connection button so the user won't be able to click on it again, and also the input box for the username, so they won't be able to change the username once the connection was established. So let's run our server, and let's run two clients, and let's connect. And you can see that everything is now disabled at the top. Let's now send a few messages. But notice what happens when I close one of these clients. The server keeps getting many empty messages. So all of the real messages that arrived before are pushed up and we cannot see them anymore. So let's get back to our server and see how we can fix this behavior. The problem is here, in the function that takes care of messages from the client. Now, as we said, the receive method is blocking. So when we call it, the server will wait for a message to arrive from the client and then it will print it. But the problem with this implementation is that if the client closed the socket from its side, on the server side, we're going to keep getting empty messages. So instead of receive, blocking and waiting for real messages, it's just going to get an empty message. So we're going to have an empty message at data, and then we're going to print it. And on the next iteration of the loop, we're going to get another empty message and print it, and so on and so forth. So what we usually do in such cases is look for empty messages. If we get an empty message, we conclude that the client closed the socket from the client's side. And then we can break the loop in the server's side. So let's check if what we got in data is an empty message. And if it is empty, we'll break the loop. But there are cases where this is not going to be enough. In some cases, the receive method might throw an error. So the right way to working with the receive method is to wrap it in a try except block. And the exception we expect to get if the client closed the connection forcefully is connection reset error. Now at the moment I won't actually do anything if we got this error, but at least we know that we take care of it. And eventually we want to close the socket from the server side, either if we had an error or if we didn't and just got an empty message, which means that the client gracefully closed the connection. So let's add a finally block and close the socket from the server side. Now, when the connection with the client is created, we get the username from this client. It can be useful to pass this username as a parameter to the thread that takes care of this specific client. So let's add it to the second parameter to the thread. And of course, we have to add a parameter for it in the threads method. And now, instead of just printing the messages when we get them from the client, we can also write who is the client we got this message from. So if we run our program and connect from the two clients, we're going to be able to see who is the client that sends each message. And another thing we can do, now that we have here the username, is to add a print when we close the socket, letting us know who is the client that disconnected. Now, in our chat application, when we get a message from a client, we want to forward this message to all of the other clients. So to do that, we're going to hold a list of all of the clients that are currently connected. First, let's initialize this list to an empty list. And when a new client connects, we're going to add it to this list. And notice that specifically what we hold in this list is the client socket, the socket that we use for communication with this client. When the client disconnects for any reason, we're going to remove it from this list. Now, when we get a message from a client, we can go over this list. And using the socket of each of the clients, we're going to forward the message to them. So let's go over the list of clients. And sock is the current socket we're going over. And we're simply going to use the send method to send the message to this socket. Now, of course, we don't want to send the message to the client that sent the message to the server, the one that the message originated from. So when we go over the list of clients, let's check if this is the client that the message originated from. And if this is the client that created the message, we're going to skip over it. So now the server forwards every message to each of the other clients. But the clients themselves don't do anything with this message yet. So let's get back to the code of the client. And once the connection with the server is created, we want to start listening to messages from the server. But once again, the receive method is blocking. So if we used it in the main thread, the whole client application would get stuck. That's why we're going to listen to messages from the server in a different thread. So once the connection with the server is created, we're going to create the new thread. And of course, we need to import threading. And now, we need to implement this method that will run in the new thread. And what we need to do in this method is to call receive, and then I'll add the message we got in the text box that shows all of the messages. And once again, notice that I had to use decode to convert the array of bytes to a string. But we don't only want to receive one message, we want to do it continuously. Receive a message, add it to the text box, and then wait for the next message. So I wrap the code of the function in a while loop. All that's left is starting the thread when the connection is made. And I'm also going to mark this thread as daemon, so it will close when the main thread closes. So let's run our server, and let's connect from the two clients. And let's now try to send a message from the first client. And we can see it here on the second client. And of course, it's also going to work the other way around. So this is working great, and now whenever a user sends a message, the message is displayed to all of the other users. But it would be very useful if the user could also see their own messages. Because right now they can only see messages from other clients, but not their own messages. So this is something that does not require communication with the server. We can do it locally within the client's application. So whenever we send a message to the server, we're also going to display it in the big text box. So I write the name of the user and then in a separate line the message itself. But I also want it to be easy for the user to identify their own messages. For this, we can use something called tag config. And as you can see, it's like a styling property. So I gave it a name, self message, and then text that uses this tag is going to be blue. So I want the messages sent by the user to use this tag, self message. So all we need to do is add it as an additional parameter to the insert method. And let's also keep the same format of the username in one line and then the message itself in another line for the messages that come from the server. So let's get back to the server's code. And when we send a message to all of the other clients, we're not just going to send the message itself, but use the same format we used on the client side. So the username, and notice that I had to use encode again to convert this string to a byte array. And data is the message itself that we got from the client that sent the message. But since data is already a byte array, we didn't need any conversions. So let's run our application and let's connect from all of the clients. And now we can start sending messages around.